welcome to Dairy Digressions, the new podcast of the American Dairy Science Association, the Journal of Dairy Science, and JDS Communications. I'm Matt Lucy, former editor-in-chief of the Journal of Dairy Science and JDS Communications, and fellow of the American Dairy Science Association. I will be your host. Dairy Digressions is where you get an inside look at the science and the scientists that are making headlines both inside and outside the dairy industry. We explore the cutting-edge research that creates knowledge and drives innovation in the production and processing of milk for human consumption. If you enjoy Dairy Digressions or have any feedback for us, please let us know at adsa@adsa.org. And hey, everyone, we want to be the global #1 dairy science podcast for 2024. To do that, we need your help. All you need to do is listen, like, subscribe, and rate us on whatever platform you're listening on, and spread the word to a friend or colleague. Now, let's get to the meeting. Today we have Dr. Pete Hansen, Distinguished Professor, Ellie Red Larson Professor of the Department of Animal Sciences at the University of Florida. Welcome, Pete.
Thank you, Matt. I'm glad to be here.
It is fantastic to have you, and out of the great state of Florida, out of the great department at the University of Florida. I guess 2 questions. Has it stopped raining yet? And how many inches of rain did you get in Florida?
I think we got about 6 inches on Saturday night, and that was graduation night for the master students in the College of Agriculture and Life Sciences. So I was there, and it was very memorable.
It was very
We didn't take all the outdoor pictures we usually take after graduation.
We are recording this in late December, and we're going to date this thing because there's a huge storm going up the East Coast right now, and I noticed it went right over Gainesville. And so that's why I'm asking about that. And the second question I have, probably more important, who was Red Larson? I mean, you're the Red Larson professor, so tell us about Red.
Well, Red Larson is a dairyman. He died probably 3-4 years ago, lived into his 90s. He was one of the seminal figures in the history of the Florida dairy industry. I think he bought his first cow when he was 10. He sold his pony and bought a heifer. And eventually Larson Dairy grew to be about 10,000 cows. It's still in business today, run by his sons, Woody and John Larson, and then Woody's sons. So it's still a major dairy in the state of Florida. And his family donated money to the university several years ago to recognize the contributions of Red. So I'm very honored to be the Red Larson professor. Our building is named after him. So yeah, it's quite an honor.
I think for people, and maybe I don't think people understand quite clearly that a lot of the origins of large dairy herd management and large dairy herds, actually that was kind of a Florida thing. Dairies around Lake Okeechobee and the south of Florida were some of the early large dairies where people sort of experimented. Well, how do you manage 1,000 cows on one platform or 10,000 cows on one platform as opposed to 60 cows in a freestall? And I think what you're saying is Larson Dairy is one of those early large dairies they must have been down in South Florida originally.
Yeah, they were in north of Miami, like a lot of dairy farms. And then as Miami area experienced big population growth, they moved north of Lake Okeechobee, near the town Okeechobee. And yeah, you're right. I mean, at one time, Larson Dairy was the largest dairy in the United States. So they were some of the first farmers to expand, into 2,000 cow units, which are still there today. So yeah, they were leading the way.
I was a Cornell grad, and I graduated from Cornell in early 1980s, and I'll never forget milking cows on 60 cow dairies or 100 cow dairies. And then I'm a University of Florida grad, and when Dr. Thatcher took me on a project down, probably was the one of Larson's dairies. I remember there was 10,000 cows on it. You just quickly learn that what I learned in terms of dairy management at Cornell wasn't going to work here. Does that make sense?
Well, I had the same experience also with Bill. we went down to do a heifer breeding trial and we checked heat with binoculars. And I thought, oh, that's different.
It's slightly different. Just throw the old books away. And of course, as you know, there's been a few, the original Large Dairy Herd Management Conference and then the subsequent conferences, and those were all supported by the American Dairy Science Association. It's really been important. I want to get back to you personally, and you must have been born in Chicago somewhere. I'm just guessing.
I was born in Chicago. I think I still have the Chicago accent.
But you're Irish. I know that, right?
Yeah, my mother is from County Wexford, and when I was a kid, she used to go back home, visit her family, and I would stay on my cousin's farm, which was a mixed farm. They milked cows for the family, and they had beef cows and sheep and pigs, and raised potatoes and barley and um, fodder for the animals on about 140 acres of land. So that's what turned me onto agriculture, really.
What was it with the so that they must have been milking like 10 cows or something. Was it something like
Less
that?
than 10 cows.
Less
Yeah.
than 10 cows.
60 cows would have been a lot of cows. And
And
things
so
have
what
changed in Ireland too. So
what's
yeah,
that?
they had about 4 or 5 cows they milked.
Yeah. And so that sort of got you in, even though that got you, they must have been milked by hand, and this
They
sort
were
of got
milked
you,
by hand.
this
Yeah.
sort of got you interested in dairy.
Yeah. You know, it was fascinating. Yeah, I loved
The-
it.
yeah, I
My
think that's it.
cousin's still farming.
Is he really?
Yeah.
Wow. On the same farm?
Yeah.
And how many cows is he milking?
Well, I don't know. He's still got beef cattle, he's still got sheep, but he's partnering with a man who has another dairy. So they put in a dairy on his farm. I don't know how many cows he's milking.
Yeah. I think, to this day there's a strong obviously dairy tradition in Ireland, and big shout out to all the scientists out there. Hey, you need to listen to Dairy Digressions, right, Pete?
That's right.
We need more Irish listeners. Okay,
That's right. It's global
it's either
impact.
you listen or you fall behind, and that's the way it is. And America's coming, okay. And so, but you can't really beat 1.4 million cows in Ireland, dairy cows, and 4.8 million people. I mean, there's just tremendous dairy tradition there, and 30 million Irish in America. That's what I hear. I don't know if that's true or not. So,
But John Joe Kavanagh, that's my cousin's name. He was
oh
very active in the Irish Farmers Association at
yeah.
one time, so he's probably pretty well known.
So you went to University of Illinois, which obviously out of Chicago. Did you start out in animal science, or did you go a
Yeah,
different direction?
no, yeah, I knew I loved science. I've always loved science, and I loved animal agriculture. So yeah, I became an animal science student.
Were you a good student, or how were you
I
as an
was a
undergrad?
good student, yeah.
You were?
I was, yeah, no, I was a good student, and I had great professors who were extremely welcoming.
Yeah.
So, by my sophomore year in college, I was doing experiments with Dr. Chuck Graves in the Department of Dairy Science.
Hmm.
So we were, I was working with his grad students, kind of like I do today with some undergrads. So yeah, no, they were extremely welcoming. Made it a very, I have very warm memories of my time at University of Illinois.
Was that the time when they had the 5 breeds at the University of Illinois? Was that before the 5 breeds were at the University of Illinois?
They had multiple breeds. I know I worked with brown Swiss cows and they had Guernsey cows and of course Holstein. I'm sure they had all 5 breeds back then. I worked in the old round dairy barn.
No way.
Yeah,
Really?
yeah,
Oh my God. So for those that don't know, if you go, first of all, University of Illinois to this day is an outstanding institution. I think, it's a public institution. People often don't necessarily recognize that, but it is an outstanding institution with tremendous history in the sciences. I think that's fair enough, Pete.
yeah.
And in a strong dairy science program. Okay, I'm gonna make a mistake here, but of course Tim Drakely, Phil Cardoso. I mean, there's Jimmy Clark, who longtime nutritionist there. I know I'm missing a ton of people, but there are friends, the American Dairy Science Association there. also there are these round barns, and which is fascinating. To this day, we were just driving. I was just there with Paul Conenough, and we drove by those barns. Was that kind of is that like is that they don't want the devil to get you into a corner kind of barn, or why were those barns
I
round?
think those were built like in the first decade of the 20th century, and people thought it would be more efficient to milk cows and to handle cows in a circle than in a flat linear barn.
Really?
So yeah, everything was built, you know, in the round.
In
So
the round.
the milk lines, they had um, tubs to clean out the manure that was on a line that went around in a circle.
It was a
They
pipe
thought that
vendor's
was more
dream, right?
efficient. I don't think there were several round barns built in the Midwest.
Yeah,
Some of them are still around,
yeah.
but
It,
obviously never caught on.
Yeah, so then they still sit up there. They're being, I don't know if there's anything in them being preserved or whatever. There's a couple of them as I remember when we drove by, not just one, maybe
I think
two,
they're in the National Registry of Historic Places, so they're protected. I don't know. I mean, I just don't know whether there's still cows in any of them.
Yeah, yeah.
I
It's
hope.
amazing, you step foot in a barn and it makes it into the National Registry. That's something, Pete. That's quite a compliment, don't you think?
Well, I don't really take credit for it personally. There were a lot of cats in that barn.
Cats.
Probably, yeah, probably like 100 cats.
Oh, I love the cats. Hey, then you moved up to the University of Wisconsin, of course, another tremendous with Ed Hauser. And
Yeah.
maybe I'm just not smart enough, but tell me about that program with Ed Hauser. What were you doing? Okay, so why Wisconsin? Why didn't you go somewhere else? How'd you end up at Wisconsin?
Well, I knew I'd be able to watch the Green Bay Packers every Sunday before,
For sure, right?
before cable TV or depending on an antenna.
Yes, yeah.
I mean, I grew up loving Wisconsin, so my parents, when we were kids, sometimes would take us on vacation to Wisconsin. So I love Wisconsin. So um, Wisconsin had a tradition of, outstanding research in reproductive physiology. I didn't know anything about this.
Yeah,
Just thought Wisconsin would be a good place to live. And
yeah.
luckily, Ed Hauser took me as his grad student and really taught me how to be a scientist.
I know you've always spoke very highly of Dr. Hauser. Is he deceased now, or is
Yeah,
he?
he's dead. Yeah, he was
Yeah,
born in 1916 and he lived, I think, to be about 97, 98.
yeah,
Uh,
fantastic.
so he
And
had a
then
long life.
I mean, how can you not be a Bears fan? You're from Chicago. What is the story?
Well, I think because I used to go up to Wisconsin, I thought Wisconsin was a great place to live.
Yeah, do you?
So when I was, I don't know, a little boy and I started watching football, I watched the Packers. I still watched them. I mean, they lost this weekend.
They lost again?
Yeah, they lost to Tampa.
Jeez, they just
So
lost to
they're
the
out of the
Giants.
playoffs. They're out of the playoffs.
Oh no. Oh no. Oh no.
The
Yeah, I
dream
was.
is deferred for another year.
Oh no. Okay. Well, I'm sorry. Well, anyway, so I did not know they lost again. Oh my gosh, they were going to turn it around. All right.
That's
So
what we thought.
what's that?
That's what we thought for a little while.
So here you go. You finish up with Ed Hauser, and then I guess some guy named Mike Roberts offers you a postdoc at the University of Florida, and your wife probably immediately goes on full scale revolt, right? Were you married at that point?
I was married
Did she want to
and,
go to Florida?
she knew marrying me that I would move around. So she
Yeah,
was okay with that. And then I think she cried when we left Wisconsin. We had a lot of friends here.
yeah,
And we left in April. It snowed when we left. And 2 days later, we were in Florida and it was like in the 80s with a warm breeze. And
yeah.
Nancy decided this was the perfect place to live.
And I know that to this day, uh, just to digress, as a graduate student, you and your wife were so accommodating when to all the students, and your wife is so gracious, and I was just visiting you guys. I can't remember a few months ago or last year or something, and the same sort of thing. So gracious, and I know she loves Florida and loves Gainesville and loves her home there, and so it's funny, these things work out. And did you know at that time you were going to go into the center of all things maternal recognition of pregnancy? Did you have a sense that something historic was going to occur at that time or not?
Well, first of all, she gave up on this idea that we would always be able to move around for my job once we got to Florida.
Once you get to Florida, you stay in Florida, huh?
Yeah, no, so, I went to Florida because I heard a seminar by Fuller Baser, who worked with Mike Roberts. And I did my postdoc with both those guys.
Oh,
And I heard a seminar by Fuller Baser that just like blew me away. And on maternal recognition of pregnancy in the pig.
on
And
the pig.
yeah, and but just the kind of research he was doing, the kind of experimental procedures was so different than what I was doing as a grad student, which was mostly measuring hormone concentrations.
Yeah.
So I knew I wanted to work with them. And then we had a student, Mike Vernon, who came from Florida to do a postdoc at Wisconsin. And he told everybody how great Florida was. So I knew I wanted to go to Florida. And so I was lucky enough to get a postdoc there and then eventually a faculty job.
Yeah, it's funny how the discovery and the work at the University of Florida on maternal recognition of pregnancy is so near and dear to many of our hearts, and that team of Thatcher and Baser and Roberts working away, and with their postdocs and their grad students, and it was quite the time. I was there about that time with Steve Helmer. He was my contemporary, and I was not working on interferon tau. We were working on other things at the time, but it was a place, right? And it continues, and there were so many reproductive biologists there at that time working both in the animal science department and also in the College of Veterinary Medicine. It was that was also quite novel, the concept that you didn't just you had an animal science department that was more than just one or two reproductive biology people. Here was a huge team, and then the collaboration across the veterinary. It was quite ahead of its time in a certain respect, wouldn't you think? Wouldn't you say?
Everybody got along.
Yeah.
And I'm sure there were egos and all that stuff, but it was never really apparent. And everybody seemed to have their labs open to everybody. And grad students would move freely from one lab to the other in the med school or in animal science, dairy science. And, there were a lot of different views of science that
Yeah.
all kind of meshed together. Like I think Fuller Baser was tremendously imaginative. Bill Thatcher was tremendously rigorous and how he did experiments, how he did statistics. Mike Roberts was very imaginative when it came to introducing new technology into science. Dr. Donald Henry Barron, was kind of the father figure of everybody and brought a lot of historical perspective to what was happening, and also believed very strongly in keeping collaboration informal and not having a chief and a bunch of little Indians, but everybody being equal. So it just meshed perfectly. And, the facilities were poor, really. The animal facilities weren't great. The lab facilities were bad. But Dr. Barron used to say, the song of the canary does not depend on the gilding on the cage.
Is that right?
Yeah.
The
And, a lot got done.
did you say the salt or the
The
soul of
song, the
the
song of the
song
canary,
of the canary did not depend on
gilding on the cage.
Dr. Dr. Barron, I forgot to mention when I talked about this collaboration, there was animal scientists. There was Dr. Barron was in the College of Medicine or the whatever it was, School of Medicine,
Right.
along with Bill Buhai was over there as well. And then, of course, everybody remembers Martin Drost over in the College of Veterinary Medicine and all the members of the team within animal and dairy science. Okay, this was across both animal and dairy science. And so, and great things came out of that collaboration. And I know you eventually transitioned into the, you did some early work on recombinant interferon tau with Claire Plant, and I can't remember her husband's name, but Claire Plant. And
Pollard.
yeah, and you guys did some early work on that. But then you're I don't know if it's fair to say, but you became quickly interested in sort of embryology, heat stress, and became sort of a leader in that. But before we talk about that, I know that we had a conversation at the DCRC meetings because you recently gave a talk on early embryonic loss, and we were both there. And I said, "Well, Pete, you're going to retire now," and you said, I don't know about that." So tell me about your. I mean, I don't know how many do you teach? Do you have any teaching?
Fuller Baser told me that his role model was Dr. Barron.
Yeah.
I said, what do you mean? He goes, well, went to work on Friday, died on Monday.
Perfect. Just had to worry about one weekend,
And he was 89.
He was 89. So it's
See,
interesting.
I teach 2 graduate courses in reproductive biology, and each one is taught every other year. And I think we're going to make that every year. And then I teach a small course on thermal biology, which is all pre-recorded. So I teach that all the time, a few
Right.
times a year. And then, I guest lecture and undergrad dairy science course.
Right.
So I still teach. I have grad students.
So how many grad students do you have?
I don't know the number. Not that
Good
many.
answer, Pete. Not sure.
Not that many. I don't know, probably about 6.
All right.
More or less.
Yeah, fantastic.
And a
And
postdoc.
and a
I'm a
postdoc.
scientist.
Yeah. And do you have a technician or no?
Yeah, I have a technician who's also a grad student. So
Okay.
Maya, who's excellent.
And what's your favorite funding source? The one with the biggest checks, right?
Yeah, whichever one funds me is my favorite at the moment. I mean, I'm sure I've gotten more funding from USDA, NIFA than anywhere else. And I've been fortunate really to get some funding from BARD, the Binational Agricultural Research and Development Fund, which is for collaborative research between Israel and the US.
Mm-hmm.
And I've occasionally gotten funding from NIH, which those are the biggest checks.
Yeah, those are. Do you have any, like, you always had, my recollection of your lab was, first of all, it was well run. Okay, well run. And people were happy. Do you have any philosophy on how you run your lab or any things that you do?
I wrote a whole paper about that.
You wrote a whole paper, so
Yeah.
much written, right? So
In
we're
Journal Animal Science.
in the
Yeah, no, I have a lot of ideas about that, which I'm gonna have a hard time verbalizing. But I'm a great believer in having fun, making science fun,
Mhm.
making it exciting. I expect a lot from my students. I expect them to do rigorous science and to work hard, to help each other. And, but, I try to have fun. I mean, I find science incredibly fun and exciting and, frustrating and painful and all that stuff. But, as long as the joy of science outweighs the agony of getting your papers rejected and getting your grants turned down, then it's worth doing. So I try to create that atmosphere among my students and in the lab. Yeah, I am organized, I think. So I try to keep the lab organized and make sure there's enough resources for everybody. And I think people teach each other. I think, if you're a lazy grad student and you come into my lab, and you see everybody working hard, enjoying themselves, you kind of do that too. Whereas if you're in a lab where nobody's ever there, I think even if you're hardworking, after a while, you're not there either.
Yeah.
So I've tried to keep that atmosphere of, purposeful fun, I guess.
Yeah. So I always, and I've probably said it on this podcast before, that science is too hard not to have fun. It's way too hard. It
Exactly.
it's hard, and the day you don't enjoy it, you better get out, and
Exactly.
and I also tell people the day you don't get upset when a paper gets rejected or a grant doesn't get funded, you better get out that day too. Okay, you're gonna have days where you're really upset, but you're gonna have great days, right? Great days. And I always feel so fortunate that I don't know how science and me came together. I know how they did come together, but I was just fortunate. And I think one of the things that's really hard is, I have a lot of undergraduate advisees, and when you can just tell they haven't found what their passion, and that's hard. That's hard when you have young people that just don't really know what's really exciting. Does that make sense to you, Pete? And
Yeah, so I mean, I found it as a freshman, honest to God, I mean, I took Animal Science 101.
yeah,
Phil Junk I went to University of Illinois thinking like, what are they going to teach in animal science? I mean,
yeah,
I already know what cattle eat and what pigs eat, and what are they going to teach us? And then my first course, Animal Science 101, Phil Shuck taught genetics and then reproduction.
yeah,
I just had never realized, people are studying these things and changing the way that animals are raised because of what they learn. It just, turned me on.
yeah.
And then, yeah, I think that's what's I'm a great believer in a master's and a PhD, not just
Hmm.
going right into a doctoral program.
Yeah.
Because sometimes, I mean, a lot of students are kind of lost in college. They don't really know what they want to do.
Hmm.
And a master's gives you the opportunity to find out whether you really like it.
Yeah.
And if you don't like research, there's nothing wrong with that. It's just one field out of many.
Yeah.
Uh, but it gives you a good chance to, readjust if
Right.
you realize it's not for you.
You
But
you and I,
I feel
yeah.
like you're very, very fortunate, very lucky.
You and I are, well, I think many of us who are in science are a lot alike. We love to go to work. We love to be at work. We're very
Yeah,
happy to be here. I'm happy to be here today. I never walk through my doors in my building and go, I wish I wasn't here. I
right.
never look at the clock. I actually have to set my cell phone with a timer because sometimes you forget what time it is. I don't have any windows in my office, so I'm like just I don't know what I am. I'm just, it's interesting, isn't it? And it's tremendously rewarding. Hey, you mentioned that, and I know this. When I was on at Florida, David Wilkinson, I believe David was at the Hebrew University.
Right.
And I know that you've had BARD funding, and BARD is U.S. Israeli Binational Agricultural Research and Development Fund. I know you've had BARD funding, and I know you've had people funded on BARD and Israelis. And we are all this is being recorded in December, and we're all thinking of um, our colleagues in that area. And the first thing I would like to say is that we have active authors at both Volcani Center and Hebrew University who are members of the American Dairy Science Association and publishers in Journal of Dairy Science. And but we have active authors throughout that region, including people of different nationalities and religious persuasions and everything else. And I would just like to say that war in that region touches really closely to dairy scientists because so much dairy science is done particularly in Israel, but other countries in that region as well. And I think we all would like peace in that. We all just want peace in that region, right? I think that's what we want. We just want peace, and I'll just quote Anthony Blinken, which is our U.S. Secretary of State. We don't have to choose between defending Israel and aiding Palestinian civilians. We can and must do both, and I think that's how we feel. But there's a tremendous amount of dairy research that's going on in that region. And I thought what was quite brave was that you sent out an email to your colleagues to help aid a kibbutz that was attacked on October 7th by Hamas. And can you just tell me about, I know you've had students, you could just tell me about that email and just tell me about your thoughts on that.
Yeah, I mean, I love science, right? One of the things I love about being in the community of scientists is it's a global society, right? And when we go to these international meetings, people from throughout the world, allies of the United States, enemies of the United States, are all there together, working on the same problems and facing some of the same issues. So it really does give you the feel for, we're all a community of mankind. And so, I mean, I feel that. And at my lab, just like your lab, we've had people from all over the world work in our lab. So I've had one of my favorite grad students, a Palestinian grad student, and Zvi Roth from Hebrew University did a postdoc with me. I know his son is in Gaza now. So, I mean, we feel, I think, personally, not directly, right? We can't know, but we sympathize with what everybody's going through. And I think probably almost all scientists around the world certainly want peace. And it especially strikes home because, like you say, so many of us have ties with Israel. So many of us have ties with the dairy industry, and the dairy industry in Israel was hit very hard on October 7th. There are quite a few kibbutzes, cooperative farms located near the border with Gaza. So several of those were attacked on October 7th, and people killed, not just Israelis, but Thai workers from other countries were killed. And those farms devastated, innocent people. So, I mean, I was just talking to Steve Roth, like, what can we do? And he suggested that we can support some of the kibbutzes that were attacked on October 7th. So I sent an email, for kibbutz Alamim, which I'm sure I'm mispronouncing. So they were one of those kibbutzes that were attacked. And yeah, I mean,
I think that was so well spoken, Pete, what you just said, so well spoken, is there's a community of scientists and we everyone wants to live in peace. And yet war is not peace. Fair enough. So, and I don't even want to continue because you said that so beautifully. So I appreciate you. I appreciate you. And for an old Chicago guy too, I mean, what is that all about? But
not always so peaceful there.
Yeah, but I just that was so beautifully said. But and it also leads into what I want to talk about. Well, I wanted to talk about everything we've been talking about, but I just wanted to talk to you about your science. And we've been talking about your science, but I want to talk more about your science. And we're going to talk about heat stress. And of course, it's not a bad transition from Israel to heat stress because, as you know, the Israelis have been very strong in this area of research for a long time. And hopefully most people understand that Israelis have outstanding dairy farms and they do it in a very arid region. And a lot of our thinking about heat stress has come out of Israel. And of course, Zvi and David Wilkinson, the people that I know, they had an interest in this topic, and they end up at Florida because Florida is a subtropical region of the United States, you know, um, I just want to compliment you on I looked you up on the Journal of Dairy Science, and I tell you, you're hitting us pretty hard. I mean, I made a little list here, and that's only page one. So congratulations. You must not be getting too much stuff rejected, Dr. Hansen. So I just want to, but now we're going to do a real digression. You've heard about the ADSA Author Loyalty Program, right? That we have just introduced.
don't think I have heard about it.
Oh, there you go. Well, we're going to bring it out in Dairy Digressions now. So ADSA has introduced a journal loyalty program. And so now, as long as you're an ADSA member, and I'm assuming you're an ADSA member,
Yeah,
and as long as you have an ORCID ID that's listed both in the journal and on Scholar One, you got those things?
I do. Yeah.
Yeah. Okay. And then, so now for your publications in ADSA journals, both JDS Communications and Journal of Dairy Science, you get points for your publications as well as your on-time reviews, and those points can be applied to page charges. So I think you're going to really score with this new program because you're pretty you're just so active in reviewing. I know you've reviewed for me, and but I think one of the things you know, Pete, you've done just so much in this whole area of heat stress and but I want to go back and I want to go, well, I've got this list, okay? You see this list of topics I want to talk about, okay?
Yeah.
But it's, you know, but we're pushing up against lunch here. So we can't go through, well, we're going to go through everything. So I hope you brought your lunch, okay?
Well, we already talked about the Green Bay Packers. I
hope you brought your lunch. But anyways, hey, let's go back to Putney's work, okay? Because Jim Putney's work, and I'm not sure if you were, I don't think he was a Thatcher student, but he
was
conceptually Putney's work and then your subsequent work on understanding the sensitivity. When are embryos sensitive to heat stress and why? So I could hack it all up, but just tell us, when are embryos sensitive to heat stress and why? And maybe some of those pivotal studies in your mind that demonstrated that.
So I think the first person to show that as the embryo advances through pregnancy, it becomes more resistant to heat stress was Ray Dutt.
Wow.
Back in 1961.
Ooh.
In the sheep. So heats, and I didn't actually know about Ray Dutt's work when we did our studies. So, but Ray Dutt exposed sheep to heat stress at different times relative to breeding. And he found that after, I don't remember the exact days, after 2 or 3 days, the embryo became resistant to heat stress. And then in 1967, there was a paper published in the Pig that found the same thing. So, yeah, Jim Putney, who was a grad student at Bill Thatcher's, he did a lot of studies in environmental chambers where he exposed cows to heat stress. So I know he did 2 studies, one where he exposed a cow from day 1 to 7. These were superovulated cows, and then he flushed the embryos and showed that cows that were exposed to heat stress, the embryos died or didn't develop more often than the embryos from the cows not exposed to heat stress. And then he did a very cool study where he induced estrus in cows, and as soon as they became an estrus, he put them in environmental chambers for 15 hours, just 15 hours. And then he took them out of the chambers and they were in a cool environment. And he showed that heat stress just for that short period of time, right around ovulation, also reduced the ability of the embryos to develop. So that was very good work. And then Bill started working with Martin Drost, where they were transferring embryos into cows during heat stress, and showed that they were getting higher pregnancy rates to embryo transfer than to artificial insemination. So we were I got hired actually by the dairy science department to study heat stress,
Yeah.
which I wasn't particularly interested in, but I did want a job, so
The I
I
get
started studying it.
the when we talk about heat stress and dairy, I um I forgot to sort of bring some of our listeners up to speed. The fact that when we talk about summertime and dairy, we deal with two things. We deal with depressed milk production, right? Loss in milk production. And we also deal with loss in fertility. And it is basically, I would say, both are some of the most unmet sort of questions in the dairy sciences, how you address these issues. And they're important. And and of course, when we think about global warming, they're only going to be more. Well, there's two things going on, right? And fair enough in dairy. I mean, you got larger, well, not larger cows, but you got cows who make more milk, more metabolic heat production with that, and also global warming. And so it's this kind of question that comes up every summer: how are we going to do with this? And we're going to dissect away on this, Pete, a little more, but we're going to dissect away on this hard, and that is that the current methods of basically spraying clean water on cows and air. Fair enough. Fans and sprinklers and cooling, that remains kind of the number one thing to do. Was that Collier that first proposed that idea of water and fans, or was that before Collier? Was that an Israeli idea? Where did that come from?
I don't know. I know that, yeah, Collier was one of the first, and then there was also work by David Wolfenson around the same time in Israel. So I don't know who came up with the idea first, but they both found, yeah, similar ideas. And, I mean, it's interesting. So yeah, we spent a lot of time working on embryo transfer as a way to reduce the impact of heat stress on fertility.
Mhm.
There was a paper published by Jeff Bewley in Journal of Dairy Science, I think, and others in 2019, where they took DHIA data and looked at summer winter differences in milk yield and in fertility. And even in the Northeast, there's a drop in milk yield, a drop in fertility in the summer. Not nearly as much as in the Southwest or the Southeast, but it's a national problem. The other thing, though, that I think is interesting is like here in Florida, there's been a big change in the dairy industry. Number of dairy farms has gone down, but the farms have gotten a lot bigger. And they've also gotten a lot better at cooling cows using kind of the same principles you were talking about. Getting a lot of ventilation in the barn with how the barn is built, and then with fans, and then using sprinklers or soakers to cause evaporative cooling of the cows. So myself, as a researcher, I don't see the same drop in fertility on commercial dairy farms in the summer now, even though global climate change is occurring, even though cows are producing more milk than ever before. I don't see the same drop in fertility in the summer now as I used to see when I got hired in the 1980s. Like we used to see pregnancy rates in the summer routinely less than 10%, less than 1 out of 10 cows inseminated got pregnant. And some producers didn't even breed cows in the summer because nothing got pregnant. On
So
the best managed farms,
yeah.
it's in the 30s or 40s even. So they have done a good job cooling cows and, managing the cow in general, managing transition period.
It's interesting that you bring that up, and it brings forward the role of science, right? And that science does make a difference, and that science does make cows more efficient and make industries more profitable. And I always tell people, you don't. This doesn't happen by magic. There's nobody beaming down information. It's people going out there and doing work and collecting data and publishing information, and then farmers and then extension agents presenting information, for example, or ourselves, we're not an extension, but and then farmers believing that science is real and can be trusted, and then farmers testing it on their own farms and saying, this does work. This does help. I am getting more milk in the tank. It's interesting, isn't it? And so, I don't like attacks on science, and we're not going to talk about attacks on science this today, okay? But maybe another podcast we'll talk about sort of clandestine attacks on the scientific community, where like trying to suggest that maybe what we do isn't for the good of all mankind. I get kind of cranked up, but we don't have time to talk about that today because we're talking about heat stress, and then we're going to take it one level more. But I gotta, before we talk about embryo transfer and blastoids, and you're looking at your watch already. It's not time
Oh,
for
I'm not.
lunch
No,
yet.
I'm not. No, I'm enjoying myself.
I want to talk about these darn Holsteins. Why are these? Because I know for a long time you used to study both Holsteins and Brahma, right? And I think that may have led to the slick
Yeah, we
gene.
still are.
What's that?
Yeah, we're still studying Brahmins.
You still have them both.
Yeah.
And so, but what is that deal? So what is okay, get to the bottom line. Okay, so you got a Brahman cow. They're not making a lot of milk, right? And they got different skin, and they got different ears, and they got different sort of body parts in general. But they still don't mind sitting out in the sun, whereas the Holsteins are going to crap out and die before you know it, right? So what is, in your opinion, give me the number 1, 2, and 3 reasons why a Brahman is less sensitive to heat, to high temp. 1, 2, and 3.
They produce less heat. Probably have smaller digestive tract.
Really?
They don't grow as much.
Really?
Yeah, that's probably one reason. And then, they have short hair, they have black skin, so that increases their heat loss to the environment, and the black skin reduces the damage to the skin by heat stress. Everybody says, well, it's because they have all that extra skin, so their surface area per unit body weight is greater than other animals. But actually, somebody back in the 1950s, McDowell, cut off all that extra skin. So something you probably would have a hard time getting approval to do. And they still regulated their body temperature better than Bos Taurus animals. I think Jersey's was his control. So we don't completely know why they better able to regulate their body temperature. They have maybe they sweat more, or they have the capacity for sweating more. Most studies that we did, they sweat less, probably because they're not as hyperthermic. They don't need to sweat.
Yeah.
But Raluca Machescu in our department has studied the sweat glands of the Brahmin, and they are bigger. So maybe they have a capacity to sweat more. When I was, as long as I'm pontificating here, like my wife always says.
Well,
when I was first hired, I had to teach this thermal biology course. I didn't know anything about thermal biology. I was like one lecture ahead of the students in the knowledge. But, one of the things that really became obvious to me was that in the beef cattle world, their solution to heat stress is to breed an animal that's thermal tolerant, that can resist heat stress. So, they cross Bos Indicus animals with Angus or whatever, and produce a Brangus or a Brayford that is more resistant to heat stress. Whereas in the dairy world, it's always been, well, let's build better barns.
Right. Yeah.
And I always wonder, why don't we look for genetic solutions to heat stress in dairy cattle? And the answer is because, the difference in production between a Brahmin and an Angus is real, but it's a lot less than the difference in production between a red Cindy or a milky, a Jeer and a Holstein, that you lose so much milk yield by crossing that it's just not practical.
Yeah, because
so then we started looking for what are the specific genes.
Yeah.
So that we could bring in a specific gene and leave behind all the genes that cause low milk yield or low growth rate. So that's kind of why we were studying Brahmins, or one reason why we were studying Brahmins. And I have not found any gene yet in the Brahmin that is responsible for their superior thermal tolerance, but that is something we're looking at.
Yeah, they
But we
are.
have, again, taken advantage of somebody else's research. Tim Olson found this slick mutation in Bos Taurus cattle that causes really short hair. So we brought that gene, or Tim brought that gene into the Holstein, and we've been doing a lot of work with that gene. And
Do
that
you
is
feel,
one
yeah,
specific gene that does confer thermal tolerance.
do you feel that, so you do feel that the benefits of slick are real? Would you yes or no?
Yes.
And do you think they're greater than, I know you did some work on white coat color versus black coat color in Holstein. Is slick greater than white coat color or not? Where does it rank?
Well, we've never compared the two. Yeah, my white coat ideas never really caught on.
Well,
Well,
they're crazy, those white Holsteins. You
that's
know
what
that.
everybody says. That's what everybody says, is that you don't want white Holsteins. I say that's because they're not heat stressed like the black ones.
Oh yeah, okay. So it's
I don't
interesting.
think
So
it's,
you haven't looked at slick on white then?
no, but white hair coat reflects about 50% of the solar radiation. Black hair coat reflects about 10%.
No way. It's that big a
Yeah.
difference?
Yeah, so it makes
Wow.
sense that a white cow can regulate her body temperature better, especially if there's a lot of solar radiation, like they're
Yes.
grazing. The problem is the white skin is associated with white hair color,
Yeah.
at least in Holstein. And I don't know whether, sunburn would be more common in a white Holstein. How big of a problem is sunburn? Probably depends on the diet. I know cows eat a lot of clover, are really prone to sunburn.
Okay.
But
Y-
yeah, the white thing is not really panned out, not really attracted a lot of positive attention.
Well, I remember it. Okay, so you
Oh
got my
yeah.
attention. Okay, so and of course, as you know, we're gonna talk to this gentleman, Dr. Geitz Labille. He's out of Ag Research. They just introduced the gene into Holstein to give him a lighter coat,
Let
and
me tell you about that gene.
gene editing. Well, he's going to talk to us next time. What?
That gene, I don't know if that exact gene, that's a dilution gene that makes the
Yeah,
black hair kind of like grayish, bluish.
yeah.
There are mutations that exist naturally in the Holstein that cause that same phenotype. So
Is that right?
Larson Dairy, we started talking about Larson Dairy. They have a strain of Holstein they call Larson Blue.
That's Larson Blue?
Yeah, that has that. I don't know if it's the same gene they mutated, but it probably is. But it's the same phenotype, that light brownish, grayish, bluish color.
Yeah.
So we did study their body temperature regulation, and it wasn't different.
Oh, wow. Well, we're curious to see. We're going to talk to him and
But it
just,
would be interesting
yeah, I'm
to
going to
look
talk
at
to
that
him and then
field.
also talk to him about his experiences with gene editing in New Zealand and that sort of thing. We're going to get him pretty soon on the podcast. And I just to,
And Jeff
uh,
Dahl has seen Holsteins with that same coat color in Poland.
in
So my
Poland,
guess is there are natural mutations that cause that dilution
interesting.
effect. But yeah, I read his paper, very interesting.
And of course, as you know, one of our previous speakers, Dr. Jenny Price from Australia, they've introduced basically breeding value. I think that's maybe not the right word, but a breeding value for heat tolerance. And it's based on sort of how a Holstein responds to increases in environmental temperature. And I'm not sure how they base it on milk production. So certain Holsteins, given a set environmental temperature, will have a lesser reduction in milk production, and they translate that into differences in terms of heat tolerance and resilience. And so We talked to Jenny about that. I'm not sure where they are in introducing that into the national breeding scheme in Australia, but there
They
are
have.
they've introduced it.
Yeah, we did some work with them on that.
Oh,
We went into dairy in California, Maddox Dairy, which is going to
mm-hmm.
be phenotyped. So we calculated the breeding value for thermal tolerance using the Australian breeding value, and then just looked at body temperature regulation, and the animals that had a high breeding value for thermal tolerance had lower body temperatures than the ones with low breeding value for thermal tolerance. Now, we also looked at seasonal variation at milk yield, but the seasonal variation was so low
Yeah.
that we weren't really able to evaluate whether the breeding value works for milk yield. But yeah, I think that comes from either Ben Hayes in Australia or Ignacy Mistal
Mm-hmm.
at University of Georgia.
Mm-hmm.
Probably Ignacy, but I'm not sure. I don't want to get into the fight over who did it first. But
Right.
what they do is look at, say, a bull's daughters, and some of those bull's daughters, their milk yield really goes down in the summer. They
Mm-hmm.
use THI, but that's temperature humidity index. So some of their bull's daughters really their milk yield drops or their conception rate drops, and then other bulls they still drop, but not as much.
Yeah.
So that's the breeding value.
The Pete, one of the things that has been interesting about your career is you identified this need in heat stress, and you identified that I'm assuming that the sensitivity of the embryo to heat stress has something to do with genome activation. I think that's something like that, or capacity.
I think so.
Before the genome is activated, they have no capacity to essentially respond. Is that fair?
Yeah, they're limited probably in how they can, if the body temperature goes up, if the local temperature the embryo is living in goes up, it tries to adjust itself to keep its cells functioning normally. But they have like one arm tied behind their back because their genes are turned off. They
Mm-hmm.
don't get turned on until about the 8 cell stage, until
Right.
about day 3. So they can't do everything a normal cell does. I think that's what's happening.
And so one of the things that's been interesting about your career is that led into your work as an embryologist and led into the concept, okay, can we circumvent this region through the in vitro production of embryos? And of course, you demonstrated with your science that, okay, if we do circumvent this time period, we can increase pregnancy rates in cows in the summer. And you demonstrated that quite nicely. And you have a series of publications on that. And then, of course, it came to, well, we need an inexpensive source of embryos if we're going to do this widely across the dairy industry. And as many of our listeners will recognize, that involves oocyte collection, in vitro maturation, in vitro fertilization, in vitro embryo culture, probably fresh or probably usually freezing. Doesn't have to involve freezing. You can transfer fresh. And that was kind of a big ask. So I'll ask you before we talk about the blastoids and everything else. Have we moved the needle in that area? In other words, do you feel like there is an inexpensive source of embryos that you could use to circumvent this period? Or has the management caught up to such an extent? You mentioned that the guys are really much better at managing heat stress, that maybe we don't need to go that direction anymore. Where do you see that? You understand the question then?
Yeah, yeah. Um, so the last part of your question, I guess, depends upon where you are, right? So there's still a lot of places in the world where fertility in the summer is pretty catastrophic. So
Mm-hmm.
I think in the more modern dairies that are existing in Florida, for example, yeah, heat stress still a problem, but not near the problem it used to be. And I bet it would never be economical to do embryo transfer to improve fertility. But there's probably places in Brazil and the Mideast, other places where fertility goes down a lot in the summer. If you could develop an inexpensive way to do embryo transfer, I think it would be worthwhile. Most of the studies I've seen by Albert DeVries, it's not really cost effective to do embryo transfer. And, there's two aspects of that. The cost of the embryo and then the cost to have the embryo put in. So the process for embryo transfer is more or less like AI, but instead of depositing the semen in the body of the uterus, you have to deposit it in the uterine horn where the corpus luteum is. So you have to be able to get that gun, that pipette, up into the uterine horn without causing any damage, and it's got to be the right uterine horn. So I think, herdsmen could be trained to do that. A lot of people argue with me about that. But in a lot of states, I mean, that's considered veterinary medicine, or the people doing it are charging from $50 to $75 a cow just to put the embryo in. So that limits the effectiveness of the procedure. I would really like to see us develop new tools for embryo transfer. Something I don't have the ability to do, but why are we, even for AI, why are we relying on such primitive technology as, grabbing the cervix through the rectum and manipulating a metal gun through the cervix? So that's one part of it. The other part is the embryo. So there's at least one company in the US, Simplot, in Idaho, that does sell frozen embryos produced in vitro. And I don't know how much they charge, say $50 to $100. But they're from slaughterhouse oocytes, which doesn't mean that they're bad, but they're probably average on average, right? Slightly less than average because cull cows, are a little bit older than the average cow in the herd. So the average breeding value is a little bit less than average, but you could always use a really great bull and still produce very good offspring. But a lot of people don't really believe that. But it's true. So there is one company that sells them, but it's still, I don't know, $50 to $100.
Right. So
Theoretically, there's a lot of potential embryos thrown away all the time, right? In an individual ovary, how many follicles are there? It depends on the age, but thousands. And people are working to find techniques to grow those follicles up to the point where you could fertilize the oocyte in vitro. If we could identify cows as they come through the slaughter plant, what their genomics are, you could take the top 1% of the cows, and if you could somehow harvest those oocytes, you could produce lots of genetically valuable embryos from slaughterhouse cows. And of course, you're interested in, even more next generation technologies. Can we make stem cells from genetically valuable embryos and use those stem cells to generate oocytes to produce embryos? We can do it if we're working with mice. Can't do it yet in cattle, but I predict someday we will be able to do that. And then you can go even further, and which is, I know you're going to talk to Carl Yang about this, make artificial embryos. I think the cover of Nature this month had a picture of an artificial embryo,
right.
Produced by Monica Zernicka Getz. So, that's really captured the imagination of scientists taking stem cells and constructing an artificial embryo with the stem cell. If you could do that and actually get a calf from it, then embryos become unlimited.
Yeah, it's an interesting question. Right now we feel like to a certain extent, semen straws are unlimited to a certain sense. You know, you can get every ejaculation 250 straws, 500 straws out of a bull. And so, and I find that I'm a big fan of stem cell podcast, and shout out to Dalen and Arun and my friends at Stem Cell Podcast, who motivated me to do this podcast. And but it's always fascinating how fast that field, particularly the embryology field in the stem cell arena, is moving. It is moving fast, you know. And as you know, the capacity to culture into advanced stages of development is moving so fast, and the capacity to coax stem cells into embryos is moving really fast. And it's an interesting question for the cow. You know, it's an interesting question. Is this going to see application? Are people going to try to produce embryos from stem cells, and you know, at a very high number? It's certainly not there yet, right? It's not like you can produce tens of thousands of embryos from stem cells in a very simple manner. I think there's a tremendous amount of loss along the way. Fair enough.
Every time I've said that'll never happen,
Never say that'll never happen.
I think I said there's no way a dairy farmer is going to buy an ultrasound machine and two pregnancy diagnosis. That's crazy.
Yeah.
Nobody's going to spend that much money.
Yeah.
Of course, now everybody's ultrasounding cows to pregnancy diagnose. You know, the technology, like you say, moves very fast, and dairy farmers, I think, love technology.
They do.
They embrace it. They're always
Yeah.
looking for it. Sometimes they get ahead of us, and we spend our time testing things they've already started doing. So I think, you know, like I like history, so I like reading about when artificial insemination was developed back in the 30s, and you know, the challenge that it represented to people's thinking about pregnancy, and so I think we're going to go through another phase like that, where some of these technologies will be very challenging to how we think about how animals are produced.
Yeah.
If I can produce, and you know, this sounds like science fiction, but if I can take cells, turn them into stem cells, like if I could take skin cells, turn them into stem cells, turn those stem cells into oocytes and sperm, then I can produce embryos from any cell.
Right.
And, you know, so for humans, that would be great if you know, you were exposed to measles when you were 15 and your spermatogonia were all destroyed, you know, you would be able to restore fertility. But I think it's going to have implications for livestock production as well. And, you know, it'll have big implications for genetics and how much inbreeding we have and how we can maintain genetic diversity. But, you know, I can tell you, all the companies that are involved in livestock genetics are very aware of this field, and many of them are trying to find ways to capitalize on it,
right,
before their competitors do. So I think your talk with Carl will be very interesting.
Yeah, I think I always tell people, I mean, I was born in 1960, but 63 years ago. Have there ever been a greater 60, 70 years of science? I mean, you look at science, you know, discovery of DNA in 1954, and look at where we are today, right? And has there ever been a greater, I mean, that's pretty heady words, right? Has there ever been a greater era in science? But, you know, and as a scientist, I feel so fortunate to have been practicing science during this era, and to experience all the evolution, you know, of science, you know. And I thought you brought up a really great point, because it reminds me of when I teach dairy science to the freshmen here. I talk all about genetics and genomics and DNA testing and all these things. And then I get to artificial insemination, and I said, well, there's one technology that hasn't changed in 60 years. And I hold up an artificial vagina, and I hold up I teach them how you freeze semen. And I'm like, well, we're kind of in how you even to a certain extent evaluate semen. It's still morphology, motility, and it's interesting, isn't it? But so I applaud your eagerness to change the way we breed cows. I mean, I really do. It's interesting. It's a technology that just hasn't changed, and it's in.
Yeah,
Pete,
why
are
don't
there any?
you get a little
Go,
micro drone to
well, I'm telling you, well, we're gonna have to leave the micro drones. But is there anything else you want to comment on before we close? It's been about an hour now.
No, I just appreciate it very much. It's been a lot. I knew it would be a lot of fun talking with you. So you
Yeah,
did not disappoint me.
so I
Thank you.
want to, yeah, I'd just like to thank you very much, Pete, for taking the time to talk. And this has been an awesome conversation. I knew it would be. I mean, I think what really comes through when I talk to you is your tremendous knowledge, your tremendous respect for the science, your knowledge of history and who did what when and their contributions. And it's just so important to have that conversation. So thank you very much for sharing.
Yeah, no, thank you. You're a little bit like that yourself. So
I appreciate that. All right. All right, everybody. That brings us to the end of our show. If you enjoy Dairy Digressions, be sure to like, subscribe, and rate us and spread the word to friend or colleague. I'd like to remind you that for show notes and more episodes of Dairy Digressions, and to learn more about the American Dairy Science Association, go to adsa.org. Until next episode, thank you everyone for listening, and thank you, Pete.
thank you, man. Thanks, everyone.